The Maritime Simulation Lab is one of the newer facilities we have here within the Marine building. It's basically an environment where we can replicate the behaviour of ships and other floating structures. It's an environment where we can read the parameters of that simulation and also inject new values into that system. Offshore renewable energy is very much about carbon effective ways of generating energy. But of course it takes carbon cost to get that wind farm deployed. So what's the optimal way of doing that? With this new simulation laboratory, we can actually measure the carbon cost of, say, deploying a large-scale structure on barges. Within this laboratory, we have full dynamic positioning capability modeled within the bridge that we have. For things like oil and gas traditionally, and now even more so for offshore wind, there's a need for vessels to hold position. Now, you can't have a crew do that for hours on end, particularly when you're looking at tolerances of less than a meter. So the idea behind dynamic positioning systems is using the ship's equipment. They will hold the ship exactly in the position as set. The classical example, because everybody can see it and visualize it, if you're taking crew out to an offshore platform and they have to get off the tender vessel onto the platform, well, how rough a sea can you realistically do that in? How will the two structures interact? What are the tolerances? And we can look at that within the lab because we do have a full DP setup in addition to conventional systems. Many of the projects we do here at the university are in close collaboration with industrial partners. We like our research to be useful, so a lot of what we will do will relate very specifically to problems that they have in industry or other sectors of government. We want the laboratories to be environments in which they can develop next generation approaches, next generation technologies with an accurate and quantitative approach.